Good morning and welcome to today's T&D World webinar titled Introducing the GridVista System, Real-Time Intelligence for Transmission Lines, sponsored by CTC Global. I'm Nikki Chandler, the Group Editorial Director for T&D World with Endeavor B2B. To begin, let me explain how you can participate in the presentation today. First off, if you have any technical difficulties during the session, just please submit those to the questions window and our technical experts will help you out. We do recommend disabling any pop-up blocking software or extensions in your browser, as those can sometimes cause issues with the webinar player. Additionally, we welcome your questions during the event today, and we'll answer as many questions as possible during the Q&A session that will follow the main presentation. But you can send in those questions at any time during the whole event. Just simply type your questions into the question window on the side of your screen and hit that submit button. To refer a colleague to today's discussion, share it on social media or access event resources and click the icons on the left side rail of your screen. You can also resize your windows for a better view. You can click on that upper right-hand corner to enlarge the windows on your screen. Also, just please be aware that today's session is being recorded and it will be available on the T&D World website within the next 24 hours. You'll be notified by email when that archive is available. All right, I'd like to go ahead and first introduce our moderator for the panel today. And then we're going to kind of jump into a short intro video before we just start the discussion. John Emery is our moderator, the VP of North America Sales and Business Development at CTC Global. Will go ahead and lead that discussion. All right, let's go ahead and cue the video. Thanks.
Let's keep our world running, supporting the homes, businesses, and infrastructure we depend on. But regular, often unseen risks threaten reliability. As demand increases, operators still lack real-time visibility into line conditions, making it harder to safely maximize capacity and act with confidence. That's why CTC Global is introducing new technology to solve this problem. Meet the GridVista System, real-time intelligence for transmission lines. GridVista delivers continuous, high-resolution data across the full length of the line, so utilities can know, not guess, asset condition. An embedded optical fiber within the conductor acts as a distributed sensing element, enabling substation-based interrogators to monitor thermal and mechanical behavior, including vibration, and to detect events dynamically along every span. This data flows into our data platform, where advanced analytics detect anomalies, predict failures, optimize dynamic line ratings, and enable AI-driven insights. By delivering real-time intelligence, GridVista optimizes capacity, strengthens grid reliability and safety, and streamlines operations. GridVista doesn't just improve visibility, it delivers peace of mind, allowing utilities to respond faster, make more informed decisions, and stay ready for what's ahead.
Hello, and thank you for joining us today to learn about CTC Global's newest innovation, the GridVista System. That video was a great overview. We're going to dive into a lot more detail throughout the next hour, and we'll be taking your questions towards the end. I'm John Emery, the CTC at CTC Global, and I'll be moderating today. If you missed the video and are just joining us now, we'll replay it again at the end of the session. We have certainly seen a tremendous interest in this technology with attendees today that include utilities of all sizes, developers, engineering consulting firms, OEMs, software companies, media, research universities, and CTC partners. In addition, nearly every continent on Earth is represented here today. We are very excited to share the details of this significant advancement in bringing more intelligence to the largest machine in the world. CTC Global is best known for developing ACCC conductor, a technology that utilities around the world already rely on to increase capacity and improve reliability. For more than 2 decades, ACCC has helped utilities unlock additional capacity on existing infrastructure without building new lines. With the GridVista system, we're leveraging that trusted infrastructure to deliver the real-time visibility utilities have long sought after but have never had: embedded, distributed line monitoring directly at the conductor. For decades, utilities have had to operate and plan around large blind spots between substations, relying on assumptions, models, and indirect measurements when making critical decisions. GridVista changes that by providing utilities with continuous real-time measurement of conductor temperature and performance along the entire span, captured from within the line itself. Today's session is about what becomes possible when uncertainty is replaced with insight, how clearer visibility into the grid can improve operations, strengthen reliability, and fundamentally change how we plan for the future. Joining me today are leaders from engineering, planning, and operations, each bringing a different perspective on what the GridVista system makes possible. Today, you'll hear from David Goyekin, Principal R&D Engineering Manager at CTC, Brent Reed, Associate Principal at Charles River Associates, who brings an independent review of the technology and its applications. Jay Casberry will finish us off. He is the Principal at Transgrid Advisors and former Senior Transmission Planner. To set the foundation, we'll begin with why GridVista was developed and what it delivers. David will walk through the system architecture and actionable insights, focused on the challenges utilities face today. David?
Thanks, John. For over a century, the transmission grid has been operated largely by inference. We model it, we estimate it, we assume margins to stay safe. That approach made sense when operating conditions were stable and headroom was abundant. That is no longer sufficient because that's no longer the case. Electrification, renewable integration, large data center loads, increasingly volatile weather, these forces are pushing transmission systems closer to their true limits. And under those conditions, inferences break down, not because the models are wrong, but because localized non-linear behavior cannot be averaged away. GridVista represents a fundamental shift in how transmission assets are understood. It moves the grid from an inferred behavior to directly observed behavior. At a system level, GridVista integrates fiber sensing and analytics with ACCC conductor to deliver continuous, distributed, high-resolution data for smarter grid decisions. The key point is visibility. Utilities can know, not guess, the state of their systems. And I repeat, know, not guess. And on top of that measured reality, the system applies advanced analytics to reduce risk and manage grid effectively under challenging conditions. This is the most important slide because this is where the difference truly lives. This fundamental shift only works if the measurement chain is real, persistent, and physically grounded. For decades, the transmission grid has operated largely blind, mostly deaf, and without a true nervous system. GridVista changes that by giving the grid a sensory layer, a nervous system, and an analytical brain, all by making those capabilities persistent. The embedded fiber optics inside the ACCC conductor core are the sensory layer, enabling 24/7 monitoring of strain, temperature, and vibration with high locational precision and long-term reliability. Because the fiber is mechanically and thermally coupled to the load-bearing core, it experiences exactly what the conductor experiences. This is how the grid sees, through continuous observation, not at isolated points, but along the asset itself in a fully distributed manner. And that matters because the transmission lines don't behave as a uniform asset. Anyone who has worked long corridors knows that adjacent spans experience very different conditions. When behavior is inferred, those differences get averaged away. When behavior is directly measured and continuously, they become visible. The interrogators are the nervous system, specialized devices that collect and process distributed strain and acoustic data, supporting diagnostics like wildfire risk reduction, galloping, ice detection, and other critical use cases. This is how the grid hears: changes in vibration, acoustic signatures, and dynamic response that indicates stress, interaction, and emerging risk. Not a handful of point sensors, but spatial awareness along the entire circuit. The software platform is the brain, continuously analyzing the measured reality and powering alerts, health indexing, and predictive analytics to help identify and prevent issues before they escalate. This is how the grid understands what it's seeing and hearing, by aligning data in space and time, establishing baselines, tracking deviation, and distinguishing between transient events, emerging risks, and long-term degradation. This is the core paradigm shift. GridVista is not inferring line behavior from proxies. It is observing it directly, continuously, and at scale. Persistence is what turns sensing into understanding. Once transmission behavior is observed, the same reality can be used across the organization. From an event detection standpoint, the system detects and alerts operators to critical abnormal events, faults, overloads, SAG violations, and possible wildfires, supporting immediate response and post-event analysis. From an asset condition and integrity standpoint, it monitors long-term degradation and external stressors to support condition-based maintenance and optimize replacement schedules, reducing O&M costs. For operations planning, it supports day-ahead scheduling and outage optimization, enables real-time operational responses such as congestion management, and provides direct ambient adjusted ratings for compliance wherever applicable. And for system planning, it provides data to support long-term infrastructure planning and load integration decisions by identifying thermal constraints and evaluating headroom for new loads. This is not a collection of disconnected use cases. It's a single observed reality supporting operations, maintenance, and planning all simultaneously. Inferences forces conservatism. Observation enables confidence. When behavior is observed directly, a different class of insight becomes possible. Thermal insight reveals true capacity available in bottlenecks, giving you insight in a distributed manner as to what the temperature on the line is or what the strain on the line is. Mechanical insights capture strain, sag, vibration, and structural loading, often early indicators of risk. Environmental insights show how weather and terrain interact with the line in practice, not in abstraction. And that measured truth supports real-world use cases like wildfire risk management, alleviating congested corridors, preventing line failures, reducing O&M spending, capacity optimization, and compliance. The point is not more data. The point is measured truth, continuously and distributedly, so action can happen before issues even escalate. Delivering this level of observation at scale requires an enterprise-grade platform. CTC Global has partnered with Google Cloud and Tapestry to transform line intelligence. CTC Global provides the embedded optical fiber technology within the ACCC conductor that delivers continuous, high-resolution line data. Google Cloud provides secure, scalable cloud infrastructure and technologies to support and augment GridVista's analytics. Tapestry contributes AI-powered grid modeling to provide additional actionable intelligence from GridVista line data and analytics. Importantly, this architecture is designed for utility governance, supporting utility-managed access, auditability, and compliance expectations, all while enabling secure scale for continuous observation. I'd like to close with this final thought. For most of its life, the transmission grid has been something we've had to infer. We've had to guess. We've had to estimate. We've had to protect ourselves with conservatism. GridVista is what it looks like when the grid stops guessing and starts to truly see. Technology like this only comes around once every decade or so, not because it's clever, but because it changes what's fundamentally possible. When the grid can see, hear, and understand its own behavior, reliability stops being reactive and it becomes intentional. Thanks, John.
Thanks, David. We have a couple questions that have come in through the Q&A text box. If there are other questions, please continue to add them in the chat and we'll address them at the end of the session. But David, for you right now, we had one that came in that I think would be good to take right here. What is the biggest benefit of having continuous distributed data along the entire line versus point sensors?
Oh, that's a great question. The biggest benefit is direct observability instead of making assumptions. Single point sensors tell you what's happening at like a few locations and force you to infer the rest of the line. Continuous distributed sensing lets you directly observe how the entire line is actually behaving, span by span and over time. That means localized issues don't get averaged away, emerging risks and can be detected earlier, and utilities can operate and plan based on measured reality, not conservative estimates driven by sparse data that's, location.
Great. Thank you. Now that we've covered how GridVista System works and the data that it provides, the next question is, what does it mean for a system level? To address this question, we asked Charles River Associates to independently evaluate how this type of data could impact operations, maintenance, and planning. Brent, over to you.
Thanks, John. Real quickly, before we jump into that independent third-party evaluation, I'd like to start off with talking about who Charles River Associates is. Charles River Associates is a leading global consulting firm that offers economic, financial, and strategic expertise to law firms, corporations, governments, and utility clients around the world. The energy practice provides core services that focus on market and competitive analysis, rate design and regulatory strategy, capital projects, transformation operations and execution support, strategy development, and regulatory compliance and analysis. We work with organizations throughout the entire energy sector and bring a very unique breadth and depth of experience to our clients. So, jumping into the actual third-party assessment, CTC Global brought in Charles River Associates. They wanted us to perform an independent third-party study of the GridVista system with a goal to review the ability to assist utilities in key areas. The GridVista study honed in on 3 key areas: expanding capacity, reducing outages, both time and impact, and streamlining operations. We'll talk about those areas in just a minute. Going back to the initial analysis, the CRA looked at multiple use case studies and tried to utilize data across multiple regions, markets, ISOs, RTOs, and utilities. The CRA team also analyzed the use and impact of the GridVista system as compared against regulatory requirements across NERC, regional entities, and multiple regulatory commissions and bodies. Just a few minutes ago, David discussed the 4 major enterprise capabilities impacted by the GridVista system. CRA started the evaluation of the potential benefits of GridVista across those 4 areas: event detection, operations, asset maintenance, and system planning. When we started looking at the system, we looked at event detection, and the system can provide precise real-time continuous line ratings and enables proactive detection of anomalies. Environmental sensing and alerts that are applicable to wildfire indication are also included within the system. And then there's a capability of integrating with data historian to enable post-event analysis. On the operations front, granular, continuous, and real-time AAR and capacity measurements are a part of the system. GridVista provides real-time data and alerts on actual line conditions, including thermal levels, and instead of forecasted or extrapolated operating conditions. GridVista is also capable of integrating asset condition data and weather system risk forecasts with existing EMS and other systems already within the organization. When we looked at asset maintenance, live line data collected to provide insights into actual asset conditions along the entire line and enable early detection of low-level corona discharges. The system has high-resolution, real-time spatial data on lightning exposure and can provide real-time actionable insight into the condition of equipment. On the system planning side, it incorporates real-time line constraints and asset health conditions with weather forecasts, seasonal risk patterns to enable dynamic scheduling of dispatch. It captures localized nonlinear load changes to enable response to load growth and is capable of integrating with data historian or EMS systems to enable more accurate risk assessments. So moving into those 3 key areas that we were really looking at, the benefit categories. When going through the analysis, the CRA team identified the potential for the significant impacts to the use of the GridVista to those 3: capacity enhancement, outage reduction, and operation streamline. With capacity enhancement, the potential for higher real-time line ratings is a big game changer. Outage reduction also has a potential to enhance system reliability and limit the outage duration. Operation streamlining, there's a potential to reduce inspection frequency and field exposure for crews, and a potential to develop proactive O&M schedules. After identifying the key benefits, the CRA team analyzed the data from those various regions, markets, ISOs, RTOs, and utilities to really try and identify potential return on investment and the impact for the utilities when they use the GridVista system. So now we'll take a look at some of those key findings. We'll start off with the capacity enhancement. Right off the bat, when looking at overloaded lines and capacity uplift needs, GridVista could save utilities up to $25 million in capital costs on 20 circuit miles of overloaded lines, ultimately benefiting the ratepayers along with the utilities. Based on data from the 10 most congested lines in SPP, congestion relief on high volume transmission corridors could potentially reduce congestion charges by up to 30%. When looking at data in CAISO, local constraints on renewable generation could be reduced up to 40%, potentially increasing revenue for renewable generators and delivering cleaner power for consumers. Moving over to outage reduction, the analysis found that the high-resolution data of the GridVista system could enable more rapid and targeted outage response time, potentially reducing outage response times by up to 99% and annual costs by up to $3,900 per 20 circuit mile line. When we looked at the value of lost load, the CRA team determined that avoiding up to 80% of outage costs could equate to approximately $8 million across 20 circuit miles in annual economic savings, again, based on ERCOT's 1 hour duration. And lastly, on operation streamlining, GridVista's data capabilities could reduce line patrols, detailed, and infrared inspection costs by up to 55% in high-risk fire areas. When we look at lower-risk fire areas, the reduction of patrol inspections and potentially elimination for the need for infrared inspections reduces inspection costs by up to 80%. Then based on average utility spend on overhead maintenance, deployment of asset management resources to lines based on prioritization could translate into annual maintenance savings of $4,600 to $9,500 on a 20-mile line. All of this data is part of the return on investment case study that was performed independently by CRA. It is available on the CTC website as well. We talked about the data points where we can add a value, a dollar value, but there's also value in the GridVista system where you can't put a dollar value on it. Strength and safety, regulatory compliance, and real-time risk management. When we look at strength and safety, you have reduced exposure hours through the technology. You're able to get high-resolution, pinpoint accuracy data that lowers time workers are spent in hazardous environments and improves workplace safety for those workers. The high-precision data provides the ability, again, to pinpoint very precise location of events, leading to less line patrols and exposure to dangerous conditions. When we look at the regulatory compliance piece, access to additional data with the enhanced analytics tied into the data historians can lead to improvements in regulatory requirements, including wildfire mitigation plan improvements, system resiliency plan improvements, system data reporting, and event analysis. And lastly, real-time risk management. Enhanced situational awareness in the real-time control room environment and in asset management can lead to a wider system view across the utility, providing additional information that can reduce overall organizational risk, whether that's identifying pre-emergent conditions, preventing an outage, or identifying equipment that needs to be repaired or replaced due to things like lightning strikes, corona discharge. And before I close out, I just want to start on a personal note. Since I started working with CTC and doing the analysis on the GridVista system, I've been impressed by the vision, the development, and the release as the system has come to market. We're at a critical point in our industry. We're facing a growing number of risks across the board, impacting reliability and resiliency. I personally believe that GridVista is a unique and innovative solution to multiple risks that are facing the utility industry. The GridVista system provides real-time actionable data and is designed to integrate with existing systems within an organization. The enhanced situational awareness, the capability to identify pre-emergent conditions, the ability to enhance outage identification, response, and cause all point to a potential and powerful reliability tool within the GridVista system. Real-time line ratings and increased capacity capability creates a very real ability to identify system conditions and system capabilities using real-time data, not static data tables used on an hourly basis. The advanced analytics create an opportunity to enhance maintenance programs and further refine system planning. Lastly, the full suite of capabilities within the GridVista system, the high-resolution data, the advanced analytics, the GridVista system creates a potential for a powerful tool that can be utilized not just by transmission owners and operators, but by market participants, regulators, developers, and other stakeholders throughout the utility industry. With that, I'll hand it back to you, John.
Thank you, Brent. We've had a tremendous number of questions come in. Let's take one right now, though, for you. From CRA's perspective, what stood out most about the value of this type of data compared to what utilities have access to today?
The biggest value is actually kind of widespread across the organization. It's the enterprise reliability solution. It impacts so many different areas within a utility. There's so many different uses that a utility can get out of it. It's not just a one and done type of tool. It's something that can be used in real-time horizon, planning horizon, can be built out into asset management, O&M. It's just a very, very powerful suite when applied across a utility.
Great, thank you. We've talked about data, analytics, and benefits of the GridVista system, but planning decisions are really where risk and cost are determined. Jay Casberry brings a planner's perspective to this discussion on how the real-time line intelligence changes the assumptions that we've relied on for years. Jay?
Thanks, John. I really appreciate the opportunity to be part of this webinar. And it's great to follow David and Brent, and really look forward to your questions, and glad to see a whole bunch of them coming into the chat and the Q&A. So thank you. Planning decisions that we make today lock in cost, risk, and reliability for many decades to come. I want to show in a few slides how GridVista can help us fundamentally change those decisions and create a better future grid faster and cheaper. I am a big fan of technology, as well as a proponent of better long-term planning. My passion for effective technology has spanned my entire career, beginning in system planning at Illinois Power, which is now Ameren, Illinois, where I was a research engineer. As a research engineer in the mid-'80s, I worked with EPRI's dialogue system to inquire databases and produce reports on what eventually became the internet. I think we can all agree that the internet is a game changer, and it was thanks to ARPA-E and many other pioneers in the industry that helped pull that resource together to help us do things better. During my career at Southwest Power Pool, I spent time at the Department of Energy on loan to the Department of Electricity Delivery and Energy Reliability, where I worked on grid modernization as we were beginning to define the smart grid. Unfortunately, I think the smart grid is still a little vague and a work in progress, but it's a clear necessity for our future needs. After I was at DOE, I was Director of Research and Development at Southwest Power Pool, where we funded advanced technology pilot projects while we worked with EPRI and others. I've consulted at Grid Strategies, and I co-authored a white paper on the merits of advanced reconductoring to support resource integration and leveraging aging infrastructure. And those same studies could be used to help with new data centers and load additions that are much more dynamic than what they were 4 or 5 years ago. I went on board full-time at the United States Department of Energy's Grid Deployment Office as it was standing up, prior to consulting with CTC Global and others focusing on advanced transmission technologies. I'm really excited about GridVista. I'm curious to hear what our viewers think about the overview from David and the compelling case studies from Brent. GridVista is a game changer, incorporating fiber optic sensing and analytics with the proven benefits of ACCC, while now leveraging the capabilities of Google and Tapestry. These are interesting times, to say the least. GridVista provides a foundation for a real smart grid. It couldn't be more timely given the unprecedented demands being placed on the bulk power system these days. The future power system not only needs lots more capacity, but must be much smarter and more agile. The static grid of the past is no longer appropriate when we have dynamic and responsive resources and loads too. The grid needs to be a flexible resource, which capitalizes on sensors and algorithms to better predict its performance and real capabilities. Fortunately, GridVista allows the industry to do just that. In this slide, I want to talk about how data is the foundation for better grid planning. Grid planning has focused in the past on deterministic, NERC-compliant plans during summer peak periods with the assumption that the reliability of the bulk power system will be addressed by adding capacity to address the needs in these snapshots. The grid is much more complex and dynamic every day with more uncertainty than ever. Off-peak periods are typically the most challenging time for operators. Affordability has become a major factor in resource allocations that are impacting the approval of prudent economic transmission plans. We have to find ways to get more capability out of the future system with less outlays. Technology that enables us to better understand key system metrics and performance will allow us to better predict future scenarios and operating states. Until now, transmission planners have simply overbuilt the grid to guard against contingencies. That brute force method is very, very expensive, and we can't afford it anymore. GridVista helps us and provides more capacity in a least cost manner to provide much more net benefits to the end consumers, to raise awareness and flexibility that's needed in grid operations. We need to help prioritize grid enhancing technologies for transfer increases and needs that may be less than 20%. On high performance conductors like ACCC in general and GridVista in particular for needs where we identify greater than 50% overloads when right sizing opportunities are observed in planning studies. This is consistent with the Brattle study recommendations that I supported less than a year ago for better implementation of transmission planning per Order 1920. As I mentioned before, data is the foundation. We need to plan the system differently. We need to look at the probabilities of grid failures, and tools like GridVista will help us get data to understand what makes sense in terms of designing the future system. We can't afford conservative assumptions and systematically overbuilding. GridVista is going to help us understand the actual line capability and its condition, which is paramount to drive future maintenance plans and things like that. Planners need to think about probabilistic approaches and not just worst case conditions. GridVista will help us do that and help us manage risk and create a better grid for everybody. If we can monitor and predict line behavior, then certainly we can plan the grid very differently. Reliability and economics are inseparable. That's a core principle that I believe fully in my heart. Planning maintenance outages are so much more efficient than unplanned emergency responses, which are very costly and impactful to consumers. GridVista helps us to be more proactive and less reactive to conditions on the system that we can see, whether that's a wildfire that's going to force an outage of a line, or whether that's lightning strikes and things like that. The capabilities of the technology are amazing, and it can help us do better planning, whether that's operational planning in the near term to help with markets, or longer term planning to basically rethink maybe how we design the system and what risk we're willing to take if we can better understand the performance of the existing assets and not just assume that a 1-year-old asset has the same failure rate as a 100-year-old asset. We need to be smarter in our assumptions and how we plan and design the system. So reliability is not just an operations issue, but data regarding asset performance can better help us with planning. So why is this urgent now? We don't have time to waste, and we can't spend 20 years proving an existing technology and getting it deployed at full scale. We need to act. We need to do things differently today, and we need to take full advantage of technologies that have been proven, like ACCC. There's thousands of applications out there, and the technology is proven. There's no other way to say it. It works. There's lower losses. There's higher capacity, more resilience, and now we've added the fiber optics and the system, GridVista system, with Tapestry and Google to help us get intelligence out of this system. So what's required going forward? We need rapid, large-scale deployment of proven technologies, in my opinion, and willingness to provide some leadership and do some things differently. We need people to be maybe a little disruptive to what's been done in the past. I know that's a challenge when we have NERC compliance and this culture of compliance in the industry that's really conservative, but we need to find applications where this makes sense. Proven technologies like ACCC must be incorporated into future plans. They should not just be a compliance with FERC orders or state mandates, but rather the right thing to do by the utility planners and operators. Planners must evolve data from deployed advanced transmission technologies as well as other grid enhancements like mandated and ambient adjusted ratings on transmission assets should be used to help us improve long-term transmission planning. Transmission portfolios of new projects are being identified in ERCOT, SPP, MISO, PJM, and other ISOs and RTOs that are tremendous. These are tens of billions of dollars of transmission investments that are needed to comply with current processes and studies. For projects that are identified as rebuilds or upgrades in the next 5-year horizon, I would suggest that stakeholders rethink the best solutions to help address the affordability and prudent planning. Maybe we ought to install a switch on a line to reduce the exposure to outages. Maybe we need to reconfigure a substation. Maybe we need to install ACCC GridVista on select lines to better understand what's really going on, and is the age of that structure really an issue or not, and not just assume that, oh, that structure's 50 years old, we need to replace it in 5 years. That may not be true. There's many 80, 90, 100-year-old structures out on the system that are just fine and would support a lighter conductor like ACCC with higher capacity. And now you think about the leverage you get from the GridVista system. We need to plan smarter, and ACCC and GridVista needs to be a key part of the planner's toolbox. Quantifying the incremental value of the data and situational awareness is tough, and it's not a metric that FERC's identified in Order 1920. But that shouldn't prohibit some leadership in utility operators and owners to develop and help remove silos between grid operators and planners. Planning and operations are converging, and GridVista can be a great facilitator in that regard. Finally, GridVista can help us lower overall cost of electric service to customers. That's a really hot topic that we need to give serious consideration. That's my prepared remarks. I'm looking forward to the questions and next steps. Back to you, John.
Thank you, Jay. A consistent theme today is that the GridVista technology goes well beyond incremental improvement. It's about knowing the reality of the grid and utilizing that knowledge to make better decisions. Load growth is accelerating, timelines are compressing, and customers can't afford 20-year validation cycles. GridVista builds intelligence on top of infrastructure utilities already trust, using technology that's proven at scale. Before we close today, we've received a number of questions, and Jay and Brent, I don't want you to get too upset, but most of the questions are going to be headed towards David. So if you do have additional questions, we probably won't get to all of them, but please add them in the text box and we'll get to as many as we can and then follow up by email for the remainder. Okay, so the first question, we're going to combine a couple of them together here. It's talking about the sensor itself. So the fiber optic, David. I'll start with the first one here and blend a couple of these together. Can the fiber wire detect mechanical damage in the core due to installation issues? And as part of that, if you could also describe just kind of how that sensor works, and then also if there's any limitations on temperature versus current ACCC.
Absolutely. So the simple question is yes. We have a distributed sensor in the form of the fiber optic. We do have interrogators. Our interrogators are typical distributed sensing interrogators, specifically a DAS and a BOTDR. And these complement one another. The DAS provides real-time sensing for fast dynamic events, things like faults, sudden mechanical disturbances, or abnormal vibrations. The BOTDR provides distributed thermal and strain measurements on a regular time interval, which is well suited for understanding loading, sag behavior, and long-term condition trends. Together, DAS and BOTDR allow GridVista to deliver both immediate event awareness and time-resolved condition monitoring. And but the question asked that was posed to us about the 180C and what is the lifetime of this optical fiber. The embedded optical fiber is designed to operate within the full thermal operating range of the conductor, including high temperature operation on the order of 180C all the way up to our emergency operating temperature of 200 degrees centigrade. Because the fiber is protected inside the conductor core and engineered for that specific environment, its expected lifetime is comparable to the conductor itself, measured in multiple decades, not years.
Thanks, David. And just to clarify for everyone, the sensor that we're talking about is the fiber optic that's in the core of the conductor. There's no additional sensors. You're not attaching anything else to the conductor itself. It is the fiber optic. And as part of that, David, there's a good question about the difference between InfoCore, which we currently have had today and for the last 4 or 5 years, that uses 4 fiber optics versus the GridVista fiber. Can you really describe the difference there quickly, please?
Absolutely. So Infocore traditionally uses our basic telecom grade fiber optics, all quadrantly placed, so that if there is a break in the carbon fiber layer, it will break or destroy the fiber optic at that given location where there's been like a fracture of the carbon fiber. This is specifically so that we can shine light from one end to the other end and see if the light passes the entire length of the conductor to ensure that we have a fully intact core. GridVista uses only one fiber optic. It's very robust. It's well protected and well suited within the carbon fiber layer. It is meant to take the load-bearing weight of the entire conductor, so that when you have an issue and a break in the carbon fiber layer, it transmits that information or that locational issue to the fiber optic in a distributed fashion to give you exactly where that break is with high precision. So it's not just sending light down one end to the other end, it's actually submitting information from one end to the other end, whereas the Infocore is just letting you know if there's a break at one particular location.
Okay, David, I'm going to switch the question order a little bit on you here, but I think this will be fine because I think this follows up very well. There was a question about hotspots and galloping, and the question is, well, I'll just read it. Hotspot and galloping point distance and phase line should be reported on the GridVista system, or could be reported on the GridVista system, if it's possible. But what level of resolution can be determined as far as where that hotspot is locationally?
Yes, that is possible, and at a level that is operationally useful. GridVista can localize hotspots, galloping, or abnormal mechanical behavior to a specific position along the entire length of the conductor, or the circuit for that matter, typically referenced as a distance from a terminal or substation and associated with a specific phase when applicable. Because the sensing is continuous and distributed, the system doesn't just say an issue exists. It identifies where along the corridor it is currently occurring, whether it is localized to a single span or has propagated to the adjacent spans, whether it's persistent or transient. So operators can answer a very practical question: which span is affected, how far from the substation, and is it isolated to one phase or evolving along the line?
So David, I'm going to put you on the spot here because I think the question also asks for, are we talking location precision within 50 feet, 10 feet, 5 feet? Can you give us a little bit of an idea of what the precision is that we can detect?
It's on a meter scale, so every 3 feet.
Perfect. Okay. We're going to give you a break, David, and we're going to go over to Brent. Brent, the question is with regard to how this compares to DLR. So let me go ahead and read the question for you. We're talking about using the data for adding capacity and reducing congestion, but navigating around the words dynamic ratings in terms of unlocking capacity. Is this not exactly what DLR is?
That's a great question, and David really kind of hit on the sensor piece and kind of talked about the fiber optics actually kind of being the sensor control. It's very similar to DLR. It has the same functions, but it's not limited. I don't want to say GridVista is a DLR tool because it's so much more. So it has that ability to adjust capacity. It reads the system in real time, provides those ratings. So it is very similar to a standard package, but GridVista is so much more than DLR. Does that kind of help a little bit? Did I answer that question for you, John?
Yeah, I think that's good, Brent. I think one of the biggest differences that David talked about, just to reiterate, is that we're actually measuring the actual physical characteristics of the conductor along the entire span at a meter level resolution, as opposed to DLR, which is pulling data from periodic sensors and trying to make more estimates. And so it's really about knowing versus estimating. But yeah, thank you for that, Brent. We're going to put the pressure back on David here. So David, thinking about the overall network, does this mean that the entire transmission chain from generation down to distribution needs to be reconductored with ACCC in order to take advantage of GridVista?
No,
David?
it does not. No, I was thinking, I want to give it some clarity. So no, it doesn't mean the entire chain must be reconductored. GridVista is like a targeted deployment strategy, typically starting with the most constrained, highest value corridors where congestion, load growth, wildfire exposure, or whatever the utility cares about, like reliability risk, is the greatest. And utilities can scale deployment based on where measured observability delivers like the most operational and planning benefits. So it's a selective reconductoring where it matters most. So it's not like a wholesale replacement.
But if a customer wanted to take advantage of the entire line from generation down into the distribution
Absolutely.
network,
Absolutely.
it would need to have the GridVista fiber optic as part of the conductor, right?
Correct.
Yeah. Okay. Perfect. All right. We're going to move a little bit more onto the intelligence and the alarming and that type of thing. So the first question, David, is how fast is the response time to detect a situation? And that gets combined with a question around when we talk about real time and being a prior transmission or a generation controls engineer, milliseconds matter on a gas turbine. But help us understand kind of what real time means in this case and how quickly we can detect a fault or an alarm.
Sure. The response time depends on the type of behavior being observed. So GridVista supports both real-time and near real-time detection. Dynamic events such as faults, sudden mechanical disturbances like rapid changes, these can be identified in real time using continuously streamed data. Slower evolving conditions like thermal trends, gradual degradation, load-driven changes, these are all captured on regular updated intervals on the order of minutes, which is sufficient for operational awareness and condition assessment. So utilities get immediate visibility for fast events and consistent time-resolved visibility for the slower ones based on direct measurement rather than delayed inferences.
And so as you think about that real time, how do you anticipate that? And maybe this is a good question for Brent. So let me throw it your way, Brent. How can the real time, it's flipping around. How can real-time intelligence help transmission line utilities manage increasing renewable energy integration such as solar and wind?
Well, I think in the real time, just having that ability to check the capacity on the line, see what the system's doing, see what's available, see how you can shift. When we start talking about having to cut off renewables because capacity issues, when you've got these constraints, well, with this tool, you get real-time data. You're looking at those lines. You're able to interact and make sure you've got that capability. You don't necessarily have to cut off a generator because of a constraint, because you can see that real-time data in that moment.
Perfect. Thank you, Brent. Okay, David, back to you. We're into some more detailed questions around hardware and comparisons with existing technology. What is the difference between OPGW and GridVista? What are the added values that we get from GridVista?
Okay. OPGW is primarily a communications asset with limited monitoring capability, typically providing point-based or segment-level indications tied to the ground wire, not the conductor itself. So if something's happening on the conductor, the OPGW might not have the same effects happening to it. Not to mention that the OPGW typically is on the order of feet above the conductor itself. So when you have an issue happening to the ground wire, it's not going to happen to the conductor itself. So GridVista is a purpose-built sensing and intelligence system that's integrated in the conductor. So it's delivering continuous distributed observations along the entire length of the conductor. And the added value is direct observability. So utilities can see how the actual conductor is behaving span by span, as opposed to running the OPGW span by span and inferring what is happening on the conductor layers below it.
Okay, thank you. So the next one's a good AI type of question. So predictive analytics requires historical training data. Given this is a new technology, how was event detection, asset condition modeling trained, or how do you anticipate it to be trained going forward?
I'd like to answer this first and then pass it on to Brent, because I feel like he can give some insights as well. But for me, on my perspective, is event detection and condition modeling don't have to start with a big trained on years type of history AI model. GridVista can start with the physics grounded observables and deterministic detection. So you would flag events based on measured departures from what your normal behavior was. So you could set your step changes, your spatial patterns, your persistence and rate of change type of indicators without needing labeled training data. And for asset conditions, We establish a baseline for that specific line during commissioning and early operation. Then you can evolve the indicators using trend and anomaly detection as operational history accumulates. So it's not like a cold start black box. It's like measured reality plus baselines plus physics informed detection. And then it improves as line history grows, as more data comes into your system, and you could build a repository. Brent, your thoughts?
No, I think you hit it perfect. And I will say one of those key points is that continuing evolution. As you gather more data and you utilize it more and more, you're going to build a bigger data stockpile. So you're going to be able to get more predictive models. So it's going to have incredible value up front, and it's just going to keep going on as you build that data from everyday use, tying it in with how your system's going and the weather around it on a day-to-day basis.
Okay, thank you, Brent. Can you speak a little bit, David, to what method of detecting wildfires this employs?
Oh, absolutely. So being a distributed sensor itself, what we would do is we would not directly try to say, hey, this is a wildfire, or hey, this is a hotspot. What you're doing is, like I just mentioned earlier, you're setting baselines. And so you set an alert when you have, let's say, a utility typically operates at 160 degrees centigrade. I'm just giving it an oddball number here. If they start to see that there's like temperature excursions below the line that's starting to reach the level of the conductor so that the fiber optic can actually detect the temperature change around it, you're going to start to see excursions on that segment of the span. And it might not be affecting the adjacent spans, but that one span is now starting to get a little hotter, and it's continuously getting hotter. The rate of change is increasing. So it went from 160 to now like 190 to 200 to 220. Now it's safe to say that there's something happening underneath that line. Now it's gone from one span to two spans to three spans. It's safe to say that there's something abnormal happening underneath your line. And if you're in a dry, not a moist or a humid environment, and you're typically within an area that's going to have wildfire risk or it's prone to those kinds of events, it's safe to say that there's something of that nature happening underneath the line. So the detection is more about meeting and reacting to temperature excursions at and below the line. I hope that answered the question.
That's perfect. Thank you, David. But we're going to flip to the other side of the coin from an environmental standpoint. Can GridVista detect ice loads?
Well, GridVista is a distributed temperature and strain measurement. So as ice accumulates on the line, specifically in the colder regions, the strain level is going to go up per span. So your sag will increase, your strain on the towers are going to increase. The fiber optic will pick this up. Now, it could be a tree fell on the line, but if you're, let's say, in New England and there's no trees that are tall enough to hit the line or near the line, it's safe to say that there's something like ice building up on the line. And ice typically builds along the entire span, not suppose like one singular location, like a point. So as the strain levels get higher and the sag starts to increase, you can generate an alert to the utility to say, hey, maybe we should go check this area out because it's concerning. We've set a baseline that we don't want our sag to reach or our strain levels to reach, and now it has reached that level. We need to probably send someone out to check it out and perhaps, fix the issue if it truly is ice loading.
Yeah, okay. I'm keeping an eye on time. We've got about 5 minutes left, and we will show the video at the end. But we've got a few more questions that I think would be valuable from the audience here. So there's a lot of interest in the installation and whether GridVista can be the same as InfoCore. So, for those of you that aren't familiar with InfoCore, that's a method of measuring and testing on a repeatable basis the condition of the core. But David, can you speak to a little bit of the difference specifically around InfoCore versus GridVista, and do they both provide proper detection on any installation issues?
Yes, in much the same way that InfoCore can detect a break in the conductor in the core via installation or through transportation of the core, the same can be done with the GridVista system. We can, at installation, detect whether there's been breaks in the core, whether there has been mishandling of the core, which led to a break in the core. And the more important thing here is that it can be done continuously through the lifespan of the conductor, meaning that it's not just an installation check, it's a post-installation check as well. You don't have to de-energize the line to see if your core is intact or the integrity of your system is still there. You could do it from installation all the way to the lifetime of the conductor.
Okay. So this one's going to be a toss-up, and maybe this will be our last one. Brent, Jay, David, maybe you can all kind of weigh in on this. We talk about direct measurements, but operations rely on highly confident forecasting of capacity. What makes your solution better at forecasting thermal capacity?
I'll let them.
David?
I'll go last on this one.
Okay. All right. Jay, you want to jump in on that?
I'm not a mechanical engineer, but I'll try. I think, and I'm sure David and Brent will add to this, but there's a lot of thermal lag in the transmission wires, as I understand it, and there's ability for systems to make very accurate projections about what's going to happen to key assets on the power system. The forecasting for wind output is leaps and bounds today, much better than it was 10, 15 years ago at Southwest Power Pool. And the algorithms, I'm sure, are much more robust. And clearly CTC Global knows the mechanics of their conductor and how it's going to respond. So I don't have much to add, but I appreciate the chance to provide something. Thank you.
I'll jump in before David comes in. The one thing I will add, and I kind of mentioned this earlier, but I want to harp on it again, is the high-end analytics, the gathering of the data, seeing what's going on the line in real-time conditions, being able to compare it. If you've got a sunny day and it's 85 degrees outside with high humidity, what's going to happen the next day you have very similar conditions with similar loading? You're going to be able to pull those analytics. You're going to be able to look at what's going on with that line across the thermal spectrum. It's going to help you really give a very precise projection on how your system's going to react in terms of the line and the capability and the thermal conditions caused by it. With that, I'll hand it over to David and let him give the engineering side of it.
Absolutely. So accurate capacity forecasting is possible because GridVista starts from a measured reality, not assumptions, and then projects forward using known physical behavior of transmission lines. I typically would think that there's 5 pillars that make this work. So you have a true measured starting point. So you have state awareness. You have traditional approaches that estimate current line state using weather proxies, static ratings, sparse point measurement. GridVista instead begins with a continuously observed thermal and mechanical state of the conductor. That means you have actual conductor temperature, actual mechanical responses, actual spatial variation along the corridor, and not to mention the feedback directly from the utility about what the actual current on the line is. Then you have the forecasting, the constraint, not the average. So transmission limits are rarely line-wide, they are localized. So because GridVista observes behavior span by span, forecasting is focused on the limiting section, the span or zone that will constrain capacity first, and how that constraint shifts with conditions. Then you have the physics-based evolution. So this is not statistical guessing. So once the current state is known, forecasting relies on well-understood physical relationships. So examples of this would be how conductor temperature responds to load and ambient conditions, how thermal changes translate into mechanical response, how inclement weather conditions are affecting the line now. Then you have the rate of change that matters. So capacity isn't just about magnitude, it's about how fast conditions are changing. And so because GridVista observes behavior continuously, it captures that thermal ramp rates, the mechanical response delays, the persistent versus the transient effects. And lastly, it's continuous validation and self-correction. So forecasts improve because they are continuously checked against itself. So as new measurements arrive, as you've made new measurements from your previous measurement, forecasts are compared to the observed outcomes. So deviations are then identified, the confidence bounds are adjusted. So this creates a closed loop. You measure, you project, you observe, and you refine. So over time, this builds line-specific understanding of typical behavior patterns, seasonal effects, and recurrent constraints.
Excellent. Thank you, guys. I appreciate it. One thing just in closing here that I'd like to add is I've worked in aircraft systems, I've worked in oil and gas, and in both of those systems, we used fiber optics pretty extensively in communications and in sensing, and a lot of different applications. And I really compare GridVista versus DLR and existing technologies. The existing view that we have is kind of like watching the sports back in the 60s and 70s, where it was grainy. You had to kind of dial it in to get the antenna right. And GridVista really delivers, 4K high definition digital TV, because now you can watch sports and you can watch, the sweat on the guy's brow. Whereas 40, 50 years ago, I remember watching sports and you could barely make it out. So, think about that analogy as potentially a reasonable comparison between the two technologies. So the takeaway is pretty clear. Reliability, resiliency, and capacity all start with better data. And when the conductor performance can be continuously monitored, operations can respond better, maintenance can be more proactive, and planning can be more effective in delivering affordable electricity. Additional GridVista system resources, including the CRA case study, are going to be available on the CTC Global website. If you'd like to continue the conversation, you can see our contact information on the screen here, info@ctcglobal.com. I want to thank all of our speakers, our partners, and everyone who joined us today from around the world. Very much appreciate your time and engagement. We're going to go ahead and close now and roll the video that we started with. Thank you, everyone.
Transmission lines keep our world running, supporting the homes, businesses, and infrastructure we depend on. But regular, often unseen risks threaten reliability. As demand increases, operators still lack real-time visibility into line conditions, making it harder to safely maximize capacity and act with confidence. That's why CTC Global is introducing new technology to solve this problem. Meet the GridVista System, real-time intelligence for transmission lines. GridVista delivers continuous, high-resolution data across the full length of the line, so utilities can know, not guess, asset condition. An embedded optical fiber within the conductor acts as a distributed sensing element, enabling substation-based interrogators to monitor thermal and mechanical behavior, including vibration, and to detect events dynamically along every span. This data flows into our data platform, where advanced analytics detect anomalies, predict failures, optimize dynamic line ratings, and enable AI-driven insights. By delivering real-time intelligence, GridVista optimizes capacity, strengthens grid reliability and safety, and streamlines operations. GridVista doesn't just improve visibility, it delivers peace of mind, allowing utilities to respond faster, make more informed decisions, and stay ready for what's ahead.